Good morning, everyone. So, this particular session, we're going to talk about the right data, right time, and the right predictive response. Yesterday was a big day for Dell, and I loved what Michael Dell, how he called data. Data is the fuel. I think we've talked about dark data, data is the fuel. There's a lot of really great things. So I'm excited to hear from our esteemed panelists today. We have Nadine Manjaro, the CEO of Beyond Machine. She's going to be Beyond Machine to Machine. She's going to be leading the panel. We have Drew Conway, who's the CEO of Alluvium. And we also have Stuart Finn. He is the VP of Sales for DataRPM. Welcome to the stage.
Stuart's coming.
Good morning.
Last minute mic change, sorry.
So good morning, everyone. Welcome. So today we're going to talk about having the right data at the right time. And so I think so far throughout this conference we've heard a lot about data. So I think my question is it the right time for predictive analytics? So we'll pose that out there. So we have two experts here, one from Alluvium. You have Drew Conway and you have Stuart Finn from DataRPM. So we're going to get their opinions on it. So, I don't know if predictive analytics is available right now. To me, that's the end goal. That's where we're all trying to get to. But I've been recently doing some research on AI because, it's the hot subject. Everybody's talking about it. And I see a lot of activities in the auto industry. But in terms of industrial IoT, I don't know if it's there yet. So you see with a lot of the acquisitions being made, you saw Intel bought Mobileye for what, $13 billion. Ford bought Argo for another $1 billion. So there are a lot of acquisitions taking place in that part of the business. But in terms of the industrial part of the business, I'd like to hear from these guys what's happening in that space. And is it there? Are we there yet?
Well,
We'll start with Drew.
Sure. So I will give you a very biased answer because I started a company that does predictive analytics in the industrial space. So yes, I think that it is time to think about predictive analytics for the industrial space. I mean, me personally, I've been building machine learning systems and data science systems. Bob last night mentioned data science is where things are going, and so I've been thinking about these problems in many different spaces. I think the important thing to kind of distinguish between what is AI, what is machine learning, and how does it affect different verticals in the industrial space, I think is no different than how we've seen kind of the commoditized stack of big data move through financial services or marketing or other industries, where the kind of principal advantage of using intelligent software systems is reducing the dimensionality of a problem. That is what the core technology and the core methods of machine learning are really good at. They're able to kind of ingest and understand large amounts of data and then feed back to expert operators, in this case, highly skilled, highly expert operators in the industrial space, where I think the use case is really, really sharp, maybe sharper than in even any other industry, to kind of create that positive feedback loop of learning that these systems should be well designed to do.
Stuart?
Good morning, everyone. So for sure, the time is now. The water's warm. Come on in. But I think the real issue is, as long as there's business challenge, there's opportunity to address and fix those business challenges. So our business was founded 5 years ago on the premise that 80% of all failures in industrial world are random and unplanned. And that's just completely unacceptable today, given the fact that all this data exists. And you'll hear, hopefully, as we talk more this morning and individually in the sessions, about how machine learning is now able to automate and solve for these unplanned and what are seemingly random issues. They're not random. They are known, we've just been unable to detect them previously. And a series of things have happened in the world: the decreasing cost of processing, the increasing availability of storage and decreasing cost, and the network, which you've heard so much about yesterday, the ability to connect all of these devices. Those three things have changed the world for us, and now we can solve for the business problems that manufacturers are facing around the world. And we've done this hundreds of times, and we'll share some use cases, I hope, both this morning and throughout the rest of the session.
Thank you, both Stuart and Drew. So, when I look at the industrial IIoT segment, I know GE came out maybe a few years ago with this whole brilliant factory concept, and their idea was to use their Predict software in their own manufacturing environment and to then learn from it and then basically develop that technology and then export it to others in the manufacturing segment. And I think you see that with other companies where they develop this technology internally, and then they, as they get better at it, they outsource it. Amazon is a great example of that. So in terms of your cognitive solutions, maybe give us an example of how it's being used for different organizations. Give one example of that and how your customers are using it to improve their business operations.
Sure, I can start. I actually think cognitive is kind of the perfect way to think about how we build software. I mean, one of the things, as I mentioned, that we really believe at our core the value of the technology is to, in some sense, shift the cognitive responsibility of a frontline operator working inside an oil refinery who's managing this massively complex system and is also awash in data. I mean, if anybody's ever seen a process manufacturing environment, there are tens or hundreds of screens with thousands of data feeds coming in. And so what our product does is leverage the learning that can come from all of that data to present to an expert who knows how to interpret what those changes are to make decisions. And so I think for us, an example of that, one of the things that I really like about having started the company is kind of seeing how different users interact with and answer and ask questions. And so one example that comes to mind is we recently started working with Power Authority up in Anchorage, Alaska. And the folks there, when we asked them, what is the thing that you like most about the software, they said, it allows us to ask questions that we didn't know that we should be asking. That there's insights from taking this complex system and distilling it down into something more cognitively manageable that allows us this kind of margin of thought that we didn't used to have. And specifically, the example that I like from there is, they were seeing this kind of power anomaly through our software that they didn't understand. It was coming from a specific part of the grid that, for all intents and purposes, seemed perfectly normal. So they kind of investigated it through further, and what they found is that what that anomaly was actually a mall that was attached to that part of the grid opening for business. But it was opening for business, and there was more power being drawn from it than they had expected that allowed them to actually investigate and then go change the way that they were working with that part of the grid because they didn't know they needed to ask that question.
Okay, great. Stuart?
So our customers, I didn't get to put up a logo slide like yesterday, but our customers are the biggest and most prestigious manufacturers around the world, the likes of Siemens, Samsung, GE, Jaguar, Land Rover. But I'll share a use case that we just finished that I think is a perfect example of what the power of automation in data science and machine learning is. So the customer came to us with a brand new set of equipment. It's commercial industrial heating and air conditioning units. And they were only able to find 0.1% anomalous events in their own data. So these are the SMEs, the data scientists, the smartest people working on their team. And the units were generating failures that they weren't able to detect in advance. And they said, hey, can you help us find the leading indicators, the early warning signs of what's causing these failures? And so DataRPM, our focus is around automating data science. it's using the traditional methods, but applying automation to it. So automation of data ingestion, automation of anomaly identification, automation of model building, and then automation of the deployment and maintenance of those models. So we ingested the exact same data set, and what did we find? 6.6% anomalous events in the data. 66 times better than the smartest people at this Global 100 manufacturer. And that sounds, the first reaction people have when you hear that is, oh, geez, you found lots of things that don't matter. Completely the opposite of the case. So when the system first ran it through, 87% of those anomalous events were able to be correlated to known failures in the equipment. And then after a little further tuning, got to 99% correlation of anomalies as predictive events for what was going to happen in the future. And that's the value of the platform. And we can talk some more about that as time goes on.
Sure. So I would imagine a lot of the customers, they hear about what this can do for their business, but they're not quite convinced yet. So how do you convince them that this is the right direction? How do you get them started? Because to me, it's either, some of them have tons of data, they have no idea what to do with it, or they have no data, they haven't been collecting it. So how do you kind of wean a customer into that process?
You can switch on.
All right, yeah, sure. So that's a really interesting question and a hard question, right? So what pushes someone over the edge? People ask me every day, who is your biggest competitor? Status quo is my biggest competitor. Doing what you always did will get you the results you always got. And as such, we all need to look inside ourselves and challenge ourselves to do something different. And for me and my team, every ounce of energy and time we spend is fighting status quo, fighting organizations, fighting people, fighting momentum of doing what you always did. And so one of the tricks or tools that we found to help do that is a challenge, right? Give me your hardest problem. Give me something you think you know about, and let me show you what you don't know. Because our entire business is about helping organizations figure out what they don't know. And that's hard, right? Because no one wants to think that they don't know everything. And so for us, the proof is in the pudding, right? Send us a data set, challenge us to help you understand what you don't know and the impact that it can have on your organization. And for us, it always comes back to business, right? How can we help the company reduce their cost, improve their productivity, focus on quality? When you do those things, good things happen to everyone.
I think, Drew, you may have a different approach. You're saying that if they have a known problem and they know this exists, or they've proven something was wrong, then you start from there by, putting an outside view of that. So can you talk a little bit about your approach?
We actually have we have grown into a kind of learning process with our customers where we fight against FUD. People know this acronym, FUD, right? Fear, uncertainty, and doubt. And I think with sort of machine learning and AI, for us walking through the door, this is what we do, this is what we present as to customers. And so there is typically, even though we're maybe having a meeting, there is a lot of fear, uncertainty, and doubt. And we work kind of both ends of the data production side, either in a real-time environment where the end user is, as we talked about yesterday, someone wearing a hard hat, someone who has fear and uncertainty and doubt around, is this software that's threatening, is an existential threat to me in my job? Is this something that's going to change that? And then, on the other side, maybe at the corporate level or in a control room side, is this actually going to work? What could it possibly know about what I'm doing and the work that I do? And so we've kind of built a process and literally built an entire product, which we call Alluvium Primer, designed to build trust with the user. And so we often start with this challenge to say, okay, we want to show you what the value of machine learning is in the context of your work with your data. So give us an example or some data for which there was some failure, right? And what we find is in most organizations, there's some event or some series of events for which there is very high salience, right? Everybody, there may be something that, to the CEO on down, they remember that day when that thing broke. And so if we can start there and say, we as a company don't actually even have to know the context around that, you guys do. But what the machine learning can do and what we can do is kind of bring you through the process to show you what the system could learn from that. I think the interesting thing is where do you go from there, right? Because once you sort of had this demo or this aha moment and say, okay, now I see what machine learning can do, what is this kind of sustainable business? And so I think it's sort of, for us, moving away from just predicting failure, right? And I think there's an interesting analog to the cybersecurity space, right, where a lot of cybersecurity companies get couched in like, well, let's prevent some intrusion. Well, the reality is day to day for most companies, even though you get these high profile breaches, it doesn't happen very often. So what is the everyday use case of machine learning inside the industrial space? So what we like to do is kind of grow from failure to improve production. What is it about learning from that system that allows us to, again, increase that cognitive and business and revenue margin for you so the system is learning and supporting decision making, discovery, and institutional knowledge building? Like those are the three pillars for us.
Great. So I have more questions, but I like to always involve the audience because I think you get more out of it. So does anyone in the audience have any specific questions for our panel? So I wanted to touch on this. So Watson is well known to everyone, right? And then Amazon has their machine learning and AI tools as well. So how do you, being younger companies and maybe not as well known, how do you combat that when you go and talk to customers?
Well, I can go for, I think, with not disparaging the efforts of other companies, I think in some sense some of the larger, fully black box solutions that are out there are some of our best marketing devices, right? I think there's a sentiment that is, I think, particularly acute in the industrial space is that the kind of master algorithm does not work. And there have been some, certainly some reported in the press failures of implementing those, not even in the industrial space, but in healthcare, in the legal space, and lots of other places. So for us, we combat that by saying, we think we apply AI and machine learning really well for supporting this kind of specific identification and learning. And we're not a professional services company, so we want to sell you a product that will sustain your, discovery, learning, and institutional knowledge building for a long time. And we're not going to give you a black box and then walk away from you. And I think that, again, I think we're really in a phase now in the industrial space where it's really a lot about just trust building. Is there something that I can provide for you that increases the efficiency and efficacy of your business, and we can build this relationship through the technology that engenders that trust with you?
So DataRPM is actually part of a much larger company. We're a division of Progress Software, $400+ million public company with 80,000 customers around the world. So we don't so much suffer from being a small company. And we solve big problems for the biggest manufacturers in the world. But to the question, I love IBM and Watson, right? They're spending hundreds of millions of dollars telling everyone in this room and everyone around the world how powerful machine learning is and that the water's warm and jump right in. And Amazon and Microsoft Azure, great partner of ours, are all promoting the fact that the time is now. So those don't scare me. In fact, I embrace them. I like to talk to my team is we want to put our sail up in the wind that they generate. But it isn't about tools, right? Somebody mentioned, I think it was Eric yesterday, that the tools have been around for a long time. There's 18 standard algorithms, but I think in that same presentation, he made the comment that it's about the people. And actually, I beg to differ. with that because we're never going to be able to train and hire enough data scientists to solve the problems that we have in our organizations today. The only way to address it is through automation and making people smarter by giving them better tools. And that's myopically what we're focused on doing.
Yeah, I agree with you because I think part of the challenge that I've heard is once you create a model, you just don't create a model, deploy it, and walk away from it. You have to keep optimizing it. So you're saying that your platform would then continuously optimize the model based on the data that's fed to it?
Yeah, thanks, Nadine. That's a great segue, right, to each and every asset that you have in your organization needs to have a model built specifically for that asset. Even when you have like assets, pick airplane engines or heating and air conditioning units or oil wells, it doesn't matter. Even if you think they're built identically, they're not identical, right? They've been operated differently, they've been maintained differently, they operate in different environments, some in the desert, some in Alaska. Pick your variables, they are not all the same. And so having one model apply to even like assets doesn't work, which is why maybe you've read or heard lots of projects get stuck in the lab, right? They get stuck in the lab because the model that they've built isn't tuned for each individual asset. And so yes, specific to DataRPM, our entire focus is around automating each and every step, right? Data ingestion, anomaly detection, model building, model deployment, and then model updating. And you have to be able to accomplish each and every one of those. And as I said, we can't hire enough smart people to do that. We need to empower the engineers who literally, if you're an industrial company, the engineers drive the business. And we need to empower them to be able to do the work using machine learning and artificial intelligence.
Yeah, I mean, I think we probably have a slightly different approach in that, I think there's a place for automation as, in a slightly maybe more of a semantic difference than anything else, but where we think of automation kind of this 80% solution in understanding what is the real interesting things to be learned from a stream of data. But that is sort of the starting point in which the humans have to be involved in interpretation, and that one of the things that's been most interesting to me in starting the company and having an opportunity to talk to folks on the executive side is that, again, getting back to some of the fear and uncertainty that they have is I think there's an appreciation that software is fundamentally changing their businesses. I think it was mentioned a few times yesterday. A lot of industrial companies' future are how quickly can they become more software driven, that this has not been a part of their business for the last 50 to 100 years. Now it is. And in addition to that, as the labor force changes and as a certain cohort retire, they take with them a tremendous amount of institutional knowledge that at this point cannot be replicated. There is no way to replicate that. So we think, well, what is the value of machine learning in that case? In addition to that kind of discovery mode, it should be institutional knowledge building. And so there's a form of automation there, which is how can we kind of automatically start to memorialize or serialize, like in a software term, how can we serialize this knowledge so that it is transferable, right? Not just in an operational sense, say from technically a downstream operation, so you're doing a forensic analysis of something out to the edge, or the other way, but how can an organization build institutional knowledge through the active and interactive learning that happens between this kind of human-computer interaction? And I think for us, and for Alluvium, and I think it's where we'll see this kind of landscape shake out, is there's this spectrum from fully automated solutions to what we sort of think of as more semi-supervised solutions, and likely there'll be some where in the middle that is the winner and that finds the most traction among customers.
So then when you're working with your customers, you would have to have like some kind of ongoing continuous engagement to make sure that what you've created for them is working and is evolving. So do you do then like a managed services kind of deal?
Through the
or-
software.
Through the
So again,
software
not,
itself.
we, you know,
Okay.
as a young company, we're certainly still navigating the landscape of, you know, big multi-billion-dollar companies and then us, and so how we have to give them a very white glove service, but ultimately, well-designed software products that are built to leverage data and machine learning should be learning from the both active and passive interactions of a user. I mean, all of us interact with these in a consumer level every day. I mean, every time you show up to Amazon, you expect Amazon to provide you a better experience because they know more about your buying habits. Same with Netflix. And in fact, Netflix takes it the other direction. You expect Netflix to produce TV shows and movies that they know you will like because they know what their users want to watch. Should be no different in terms of how the interaction happens in software for an industrial user. Obviously, it's a completely orthogonal use case, but this approach to building software should more or less just be moved over.
Great. Question, Eric?
I'm going to suck up some more options.
Okay.
How do you manage the internal expectations of the customer? For example, I run across a number of various managers and directors, and their expectation is machine learning, predictive analytics, it's going to deliver the right answer. We can automate it and done and move on and build on that. When in reality, it's delivering a probability density built upon context, data input, business rules at a certain point in time, which is always dynamic, which will always modify. And in addition, the moment you do automate it, you change the process, you change the business model, which by definition changes the context the model operates. I keep thinking of Willy Wonka and the Chocolate Factory, whether you like Johnny Depp or not.
Wonder how much IoT you had in there.
Charlie's dad. Charlie's dad put the caps on the toothpaste, and he was automated out of existence. And at the end of the movie, his job was to fix the machine that automated putting the caps on the toothpaste. And fundamentally, isn't that what we're talking about, is an evolutionary organic process where even if you automate and you put champion and challenger models, it will require continual dynamic change to improve as the business model, the context, the technologies, the industrial processes modify and change over time. So how do you set that expectation to say, you're not buying into a one and done solution, you're buying into a new way of doing business in a market that is changing every 6 months and is virtually unpredictable?
Yeah, so I'll start. So we're working through those exact challenges. One of our clients in the UK spent a year proving to themselves that the technology works, can solve real business problems, but the barrier to deployment had nothing to do with the technology. It's all process related. And so literally 2 weeks ago, they got the entire $5 billion division together, all the managers, and laid out the strategy and the change that's going to be required in how everyone thinks about their job and how data is going to be implemented to help them change the way they execute. So for sure, there's no panacea, right? Machines are only as smart as the data that we give them. However, they are starting to learn, thus the term machine learning, right? And learning from the experiences and being able to forecast or predict what we don't know, right? The human mind is challenged because we don't know what we don't know. And that's really this problem with this whole IoT space and the data is we don't know what the machine is really telling us. And once we do learn, it's going to change our physics-based approach, the design of our products, and the implementation of that technology or that process across our entire business.
Yeah, and I would only follow up to say, what I think and the kind of philosophy of Alluvium is if you're buying a software product and or service that does not change and evolve the way that you do your business, especially if it's based on learning through machine learning, then that is an ineffective and a failed product, right? I think at a very high level, in a few years, maybe 5, maybe 10, when this body meets again, I think we'll have thought a lot about what was the fundamental success of kind of industrial IoT as a kind of change in business. And I believe that we will not be talking about the means of production, right? Arizona Public Services will produce energy. That is what it will do. But how you will think about understanding and evaluating the risk of that business, understanding and evaluating how you can, where that kind of productive margin grows and shrinks based on that knowledge, that will be the fundamental change of this, and how we will kind of evolve from thinking about it through retrospective analysis up through, all right, in real time, I can fix that problem, and that little margin in a cumulative sense will have fundamentally changed how a lot of these businesses work, but they're still going to produce energy, produce tires, refine gasoline. All these things will be the same, but the software will just change how we think about understanding that business. So just to answer the question, when we walk in the door, we say we don't know the answer, right? You're the expert. The software can get you to asking the right question and getting a better answer more quickly. And for us, that's kind of, again, increasing that cognitive margin for our customers.
Yeah, to me, it seemed like it's a longer relationship than even deploying the devices to collect the data. Because I was reading somewhere they were saying that, once you deploy the software, then even if, like you were saying, Stuart, you'd have to do it for each individual product because there are nuances with that. But my understanding is that you would still have to go back and evaluate it over time, and you have to implement some kind of DevOps to optimize the algorithms and then redeploy it every so often to keep it accurate. Because like you said, the output is just as good as the input, the data that you're putting in. And so it's not a one-time thing, it's a continuous process. And so, do you employ DevOps or those kind of techniques in your solutions to ensure that happens?
Sure, Nadine, thanks. So the question, just to reformulate or to re-express, is how do you keep the models current, right? Because we built the perfect model, we tuned it for each and every asset, but over time, that asset's gonna change, right? It's gonna go from winter to summer, it's gonna go from not being maintained to being maintained, maybe rebuilt. All different kinds of changes going to happen in that asset. So we constantly need to be streaming the new data from that system and tuning the model. And yes, for us, that's exactly what the platform does. Again, you can't hire enough people to rebuild the models every month or every quarter or every 6 months. The system needs to understand when the model is getting out of date, when it's shifting, and retune itself. And that's exactly what we provide to the customers, and exactly what's required, and why projects today have gotten stuck in the lab and not been able to be deployed across multiple countries and multiple systems.
Okay.
Yeah. I mean, I would agree with that. I mean, a sort of technical philosophy we have at Alluvium is that your model should be similar to your opinion, strong but weakly held. And so, we have well-defined models that can understand data as it exists in the moment, but we've built technology that is explicitly designed for brittle inputs or new inputs or changing requirements. So literally using input data as a form of configuration, right? When new data comes online, how does that change the feature vector that you're actually producing to maybe predict failure or understand what does that new variable mean with respect to the overall stability of this plant and how that works.
Okay. Well, we're almost out of time. Do we have time for one question from the audience? Anyone? Sure.
So a little bit to distract from the topic, but I think it's important. Disruption. You're software engineers, right?
Once upon a time.
For me, no, I'm a simpleton. I'm not as smart
but you
as
understand
everyone
software
else
engineering.
in the room.
So, concurrency and Golang and its role in what's happening with IoT. You're probably aware that Golang is actively used in a lot of those projects, largely because of concurrency that's built in. Do you have any opinions on that?
Sure, I do. Go is a fantastic language. We made a technical choice to use Scala, particular functional Scala, mostly because we needed access to the JVM. Right, so all of our software is built on top of the JVM as a means of universal deployment. As a technical digression, Scala as a language has fantastic abstractions for a lot of the fundamental things that we want to do. If folks want to find me and find Chris, who's sitting right next to you, we can talk about some of the decisions that we made in actually taking a fully functional approach to that, and I sort of alluded to it before. Having the ability to deploy a learning algorithm that is, in some sense, brittle and is able to reconfigure itself based on data means that we have to have these kind of weakly defined abstractions in deployment that can then learn from data as a form of configuration. Now, there's no reason you couldn't do that in Go. We have an engineering team who made a decision to work with Scala as that language, but I don't want people to start burning the building down and throwing chairs to have a programming language discussion. That's for a different conference. We can do that later.
Well,
I thought I was going to be next.
I hope you guys found this session informative. You have Drew and Stuart are going to be around, so if you have additional questions, you want to take a deeper dive with them, they'll be here for the rest of the conference. Thank you very much for your time.
Thank you.
Thank you.